Good evening, everyone. Good evening. Good evening, everyone. I welcome you all again to NEET Elite for one last time, I believe. I hope you guys are doing great, having a good time. So people, before starting the session, I just wanted to ask you about the nervousness, right? Are you guys excited about the tomorrow's exam, or you guys are feeling some nervousness, right? You can honestly let me know in the chat box. Welcome back, everyone. Welcome back. Just let me know, are you guys super duper excited about the exam, or you guys are nervous? Well, I'm basically getting nervous for you guys, right? I'm not sure about you, but I'm for sure getting nervous for you. Yeah? Okay? And I'm sure due to the nervousness, you guys are going to watch this session, right? Yes? So we will just 15 to 16 more hours, right? Then your NEET 2021 will be there, yeah? And I'm sure you guys are going to kill it, because I'm sure you guys would have worked hard for these couple of years, yeah? And I'm sure you guys are going to shoot the bullseye, exactly, right? So have that confidence, have that faith in yourself, right? Do enter the examination center like the boss, and do leave the examination center like the boss, right? Okay, and I'm sure you guys are going to do great, okay? And I'm sure, I hope everything falls into place, okay? Perfect. Exactly, finally the day has come, yeah? How long is the session? The session is just going to be for 1 hour, right? I have come up with some 45 questions. We'll try to solve these 45 questions, right? So that one last time you get to know the level of your tomorrow's NEET examination. Right, people? Yes? Perfect. So before starting the session, the ones who are new to the channel, let me introduce myself. Well, people, my name is Wassim Sir, and I'm your chemistry master teacher writer on this NEET Elite channel, right? The ones who have not liked the video yet, please do like the video, share the video, and do subscribe to the channel for the last time, right? So do like the video, share the video to friends, and do subscribe to the channel as well, okay? Tonight, I'm not going to say how many of you are super duper excited about this session, and I'm sure you guys are nervous, right? Yes, so I'm not going to ask you about the excitement, right? So let's get going, let's get started with the first question of the today's short series, which is going to be on your screen in 3, 2, 1, and now, right? This is the first question on your screen, people, right? Give it a try. You guys can let me know its answer in the chats. Which among the following salt solution is basic in nature, right? You're given with certain salt solutions, and you're supposed to check which of the following salt solution is basic in nature, right? Just let me know its answer in the chats. Let me know, people, its answer in the chat box fast. Yes, Gayatri, tomorrow is your day. I wish you all the luck. Well, I can see majority of the people are coming up with option A. Let's exactly get to know, is it actually going to be option A or not? Look here, guys. It's a very simple and basic question. Just have a look on it. What I need to check, basically, which among the following salt solution is basic in nature, right? You need to see among these 4 solutions, which of the following is basic, correct? If you look at the first salt solution, it is sodium acetate, right? It is sodium acetate, which is basically CH3COONA, right? This is something which we call as sodium acetate. In your sodium acetate, you have got basically 2 ions. One is going to be CH3CO negative, another one is going to be Na positive. First of all, it's a salt. It is a salt. Absolutely, it's a salt, right? Yes. So CH3CO negative part, it definitely would have come from CH3COH, and Na positive would have come from NaOH, right, people? This CH3COH is the example of the weak acid, as you all must be knowing, right? This NaOH, it is the example of the strong base. So the first solution which I have right here, it is the salt of weak acid and strong base. If it is the solution of a salt of weak acid and strong base, definitely its pH is going to be greater than 7. It is going to be basic in nature. So absolutely, people, option A is the one which is going to be basic among all. I'm not going to check the rest of the solutions, right? Okay, rest of the solutions you can check on your own. This is ammonium chloride, NH4Cl, right? NH4Cl, correct? If I talk about this one, this is NH4Cl, in which you have got 2 types of ions. One is NH4 positive, Cl negative. NH4 positive would have come from NH4OH, and Cl negative would have come from HCl. Yes, people? NH4OH is a weak base, HCl is a strong acid, so it is a salt of weak base and a strong acid. In the similar fashion, you are going to check the rest of the things. I'm sure every single thing is clear till here, right? Let's move on directly to one more question. Well, people, this is one more question from the chapter solution. Again, a very simple and basic question, provided you know the formula for the relative lowering in vapor pressure, right, people? Let's exactly see how this sort of a question is to be solved. Understand properly. See, guys, as per the question is concerned, if 8 grams of a non-electrolyte solute is dissolved in 114 grams of N-octane, right, to reduce its vapor pressure to 80%, the molar mass of the solute will be, right, I'm supposed to calculate the molar mass of solute. You guys can give it a try and let me know its answer in the charts, right, people? Let's exactly see how this sort of equation is to be solved. Understand properly. So first of all, 8 grams of solute is given to me. So mass of solute, which I represent by WB, that's something which is given to me as 8 grams, right? Mass of the solvent, which solvent is my octane, and mass of solvent is something which I represent by WA. Its value is given to me as 114 grams, right, people? Okay, so I've got the solvent as octane. So let's assume this is the pure octane in the container. And vapor pressure of this pure octane, I'm representing by P naught A. Now what I'm doing is, I'm adding some non-volatile solute towards it. So I'll be getting a solution. Right here. Yes, and it's mentioned the vapor pressure of this solution is how much? See, guys, if 8 grams of non-electrolyte solute is dissolved in 114 grams of N-octane to reduce its vapor pressure to 80%. That means the vapor pressure of this solution, which I represent by PS, it is the 80% of initial one. So it's going to be 80% of P naught, which is simply going to be 0.8 P naught A, right? This is the vapor pressure of the solution, correct? I'm assuming the solution to be very dilute. Now, how will I be solving this question? Simple. You know the relation, that is P naught A minus PS divided by P naught A, right? Which is something which we call as relative lowering in vapor pressure. That's something which is equal to the mole fraction of solute, right? And mole fraction of solute I can represent as number of moles of solute divided by total moles present in the solution, Na plus Nb, right, people? Now I'm assuming the solution to be very dilute. If I'm assuming the solution to be very dilute, that means number of moles of B will be far less than number of moles of A. That means I can neglect this Nb term over here. So the formula becomes P naught A minus PS divided by P naught A will be equal to Nb divided by Na, right? Now, how to approach this question after this? See, guys, it's going to be simply P naught A, and PS is nothing, that is 0.8 P naught A divided by P naught A is equal to number of moles of solute will be simply equal to mass of solute. Mass of solute is given to me as 8 grams divided by molar mass of solute, which I represent by Mb, divided by number of moles of solvent, which is basically mass of the solvent, which is given to me as 114 grams, divided by molar mass of solvent, molar mass of octane, that all of you must be knowing, that's again 114, correct? Can I say P naught A, P naught A, P naught A gets cancelled everywhere. So what do I get at the end? It's going to be 1 minus 0.8, which comes out to be 0.2, right? Yes, it's almost done, right, people? It's almost done. Yeah, the question is done and dusted. See, P naught A you are taking as common. So P naught A, P naught gets cancelled. So 1 minus 0.8 is going to be 0.2 is equal to this term gets cancelled. So it becomes 8 divided by Mb. So by solving this, you get the molar mass of solute. I'm sure about it, right? I'm sure you got the answer of the question, right, people? So finally, you get the answer of the question as 40, right? Okay, so people are saying option B is the answer. Absolutely, people. Option B is going to be the answer of the question, right? I forgot to tell you one thing. Okay, it was divided by 100, right? It was divided by P naught A. Yeah? Okay, moving on to one more question. Identify the compound A in the following reaction. This is the reaction given to me, and in this reaction you are getting benzaldehyde as the product, right? And people, have a look on the reagent exactly. What do we call this reagent? PDBSO4. What do we call it as? What do we call this as? Is it going to be the Rosenmund's reduction, right? Because you are using the Rosenmund's catalyst, which is PDBSO4, right? So it's absolutely going to be the Rosenmund's reduction. And in the Rosenmund's reduction, which of the substrate do I use in this reaction? It's absolutely going to be benzyl chloride when we do the when we do the reduction of benzyl chloride by using the catalyst, we get something as benzaldehyde. So answer of this question is absolutely going to be benzoyl chloride, right? Okay, I'm sure it's clear to everyone. So this is the substrate. This is the substrate, right, from which you are getting this as the product, right? How did I answer this question? I identified the reagent over here. Yes, I identified the catalyst, and by means of that, I solved the equation carefully, yeah? So option B is going to be the answer of this question. It's going to be the Rosenmann's reduction simple. Okay, the half-life of a zero-order reaction having 0.02 molar initial concentration of the reactant is 100 seconds. The rate constant for this reaction will be. What is going to be the answer of this question, people? Give it a try. Let me know its answer fast. It's a zero-order reaction, right? Let's say this is the zero-order reaction. A gives B. It is a zero-order reaction that's given to me. Its rate constant is, for example, K, right? At time t is equal to 0, the initial concentration of A, which I represented by A naught, that's something which is given to me as 0.02 molar. 0.02 molar, right? Initial concentration of reactant is given to me as 0.02 molar. And at the same time, the half-life of this reaction is also given to me, T1 by 2. T1 by 2 of this zero-order reaction is again given to me as 100 seconds, right? People, if you remember the half-life of the zero-order reaction, which is nothing, which is A naught divided by 2K. A naught divided by 2K. This value is basically equal to 100. So from here, you can easily calculate the rate constant of the reaction K. That's going to be equal to A naught divided by 2 multiplied by 100. As simple as that. What is the value of A naught? A naught value is given to me as per the equation. That is 0.02 divided by 200. You can solve this, get the answer in second inverse, right? Because the time was given in seconds, yeah? Okay, you can solve it further, get the final answer of the equation. I'm sure it's clear to everyone. Yes, Teja, the top 100 series is enough, yeah? Perfect. All right, let's move on. This is the final answer which you'll be getting after solving this, right? Moving on to one more question. The oxidation number of the underlined atom in the following species is given. Identify the incorrect option. People, can you just identify the incorrect option, right? I'm looking at your chats only on the screen. Just let me know its answer. It's a very simple one, and you can expect these sort of questions, guys. I'm telling you, right? Okay, so what is going to be the answer of this question? You need to identify the incorrect one. You need to identify the incorrect match. See, if you look at the second option carefully, it's mentioned that oxidation state of this oxygen is -1. Is it possible? Is it possible this oxygen is going to have the oxidation state of -1? See guys, this is Cu2, this is O1. You would have studied in your class 9th itself. You are simply going to do the crisscross thing if you remember, right? Okay, so it is going to be Cu +1 and O di negative. So basically oxidation state of oxygen is not supposed to be -1 here, it's supposed to be -2. So in the option second, the oxidation state of oxygen which is mentioned as -1, that's absolutely incorrect, and I was supposed to take the incorrect option only, right? In all the other cases you can check it out, it's going to be correct, right? See, hydrogen over here shows +1 oxygen state. Au, let's assume its oxygen state is X. Cl will show -1 multiplied by 4, net charge is 0. From here you get the value of X as 3, right? Similarly, in case of ClO3 negative, it's absolutely going to be +5. And similarly, in case of K2Cr2O7, the oxidation state of chromium is simply going to be +6. This is very simple based on the simple formula of calculation of oxidation states, right? I'm directly moving on to one more question. This is one more question, people. A very simple, ordinary and basic question, and I'm sure you guys are going to kill this one as well. Just let me know its answer in the chats first. Just let me know, people. Just let me know. Anusha, it happens to everyone. When I wrote the JEE at my time, even I was very anxious before the examination, right? It is just you need to have proper sleep tonight, right? So do sleep properly. Do not study anything tonight, right? Okay, right after this session, I want you guys to sleep. Wake up in the morning, right? Do not go through any topic at all, right? If you have the list of the formulas, just go through the list of the formulas in the morning. That's all. That's all what I want from you. Okay? Perfect. So majority of the people are coming up with option B. Let's exactly get to know, is option B going to be the correct answer or not? So basically, what are you supposed to calculate as per the question? The solubility product of a salt of the type AB, right? So I've got the salt of the type AB, which I'm considering as the weak electrolyte, which will undergo dissociation as A positive aqueous plus B negative aqueous. Let's assume solubility of this salt is S. So concentration of A positive is going to be S, concentration of B negative is going to be S. If I simply write the expression for KSP, it's going to be S square, right? So from here you can get the value of S, which is going to be KSP raised to the power 1 by 2, right? What is S basically? S is the molarity of the solution as well, right? That's something which I was supposed to calculate, right? What is the molarity of a standard solution? That means you're supposed to calculate solubility. It is just the language of the equation is different. Rest everything is same, yeah? Okay? So KSP value must be given to you as per the question, which is 4 in 10 raised to the power minus 8. So 4 multiplied by 10 raised to the power minus 8 raised to the power 1 by 2. This value will come out to be 2 into 10 raised to the power minus 4 molar. This is going to be the solubility as well as the molarity of its standard solution. So the correct answer is absolutely going to be option 2. Yeah? I'm sure it's clear. Right, people? Let's move on to one more question then. This is one more question on your screen. Which of the following substituted phenols is the strong acid, right? This is something which I assume all of you must answer properly. You all must be familiar with the fact. Okay, before talking about that, see. This is OH right here. This is OH. This is OH. This is OH, correct? I've selected my reference. OH is common to everyone, right? Now, people, you all must be familiar with the fact acidic strength is directly proportional to minus effects. Acidic strength is directly proportional to minus effects, right? And you all must be familiar with the fact as well, minus M dominates over minus H and minus H dominates over minus I, right? This NO2 is currently at the para position, right? And when NO2, when nitro group is present at the para position, it definitely operates minus M. This is OCH3. This oxygen has got 2 lone pairs. So which effect this OCH3 is going to operate at the para position? It's going to be plus N, right? And this is simply the ethyl group. It's going to operate plus I effect, right? As I told you, acidic strength is directly proportional to minus effect, right? And minus M dominates over everything, okay? And there is only one option in which we have got a group showing minus M effect, which is the second one. So second one is absolutely going to be the maximum acidic among all, right? I'm sure it's again clear to everyone. And if you're not liked the video yet, please do like the video, share the video with your friends, and do subscribe to the channel as well, yeah? Perfect. And people, just right after your exam tomorrow, see, your examination gets over at 5. I'll get the paper around at 5:10, and at 5:15 sharp, right, I'll be coming up with the paper discussion over here, right? Okay, so do not forget to attend that session as well. So it is, basically I'm going to do the paper discussion on 2 channels. One is going to be Biotonic, Wari Mam's channel, and this channel as well. So on 2 channels, I'll be doing the paper discussion. On this channel, it's going to be in English. On the other channel, Wani Mam's Biotonic channel, it's going to be in Hindi, yeah? So you guys can watch the solutions of the tomorrow's paper right after the session, right after the 15 minutes, right? Okay, which of the following will not undergo SN1 reaction with the OH negative? What do you think about this one, people? What do you think about this one? Just let me know its answer fast. A very simpler one, and I'm sure you're going to kill this one as well, yeah? Let me know fast in the chat box. Which of the following will not undergo SN1 reaction with OH negative? First of all, your SN1 reactions, they get completed in 2 steps if you remember. The first step is the ionization step in which you get the carbocation, right? Okay. And depending on the stability of that carbocation, you exactly get to know whether the reaction undergoes SN1 or not, right? So which of the following will not undergo SN1? See, just take Cl negative out from here, you get the positive charge on this carbon. If you take Cl negative out from here, you get positive charge of this carbon. If you take Cl negative out from here, positive charge on this carbon. If you take Cl negative out from here, positive charge on this carbon, right? You need to see which carbocation is the unstable among all. See, the first one, it is a benzyl carbocation, which is very stable, as you all must be familiar with the fact, because this positive charge is in resonance, it's in conjugation with the ring, right? Now, similarly, in the second case, this positive charge is again in conjugation, right? So it is going to participate in the resonance, which makes it stable, right? This is a 3-degree carbocation, which is stabilized by hyperconjugation. And this carbocation, it is basically a 1-degree carbocation, which is not stabilized by anything, right? So this is the most unstable carbocation which you are getting among all. And wherever you get the most unstable carbocation, that reagent is not going to undergo SN1 with OH negative. So option D is absolutely going to be the one which is going to be correct answer of this question. I'm sure it's again clear to every single guy. Yeah? Okay, perfect. Let's move on directly to one more question. This is one more question, people. A very simple, ordinary and basic question, right? And these sort of questions, these types of questions, if you see the recent JEE mains examinations, right, which were held in August, April, May, right? In every session, at least one question of this type was asked. So you can expect again these sort of questions, this type of question in the tomorrow's examination, right? Okay, let's exactly see, as you all must be familiar with, How do we calculate total nodes? There is a formula for that. Total nodes are calculated by the formula n minus 1, right? These total nodes are basically of two types. One is called as the radial node, or you call this radial node as the spherical node as well, which is calculated by the formula n minus L minus 1, right? And how do we calculate the angular nodes? Angular nodes, people, is simply calculated by the value of L, as simple as that. Check it out now. See, we have got 3s, right? We have got 3s. For 3s, what is the value of principal quantum number? It is 3. For s subshell, what is the value of L? That is 0. What do I need to calculate? The number of angular nodes and radial nodes, right? L is equal to 0. That means angular nodes are 0, right? That means angular nodes are 0, right? N minus L minus 1. So 3 minus 0 minus 1 comes out to be 2. So there are basically 2 radial nodes and 0 angular node, right? That means 0 angular node and 2 radial nodes. So option 2 is absolutely going to be the answer of this question. I'm sure this is clear to everyone. Yeah? Okay, let's move on directly to one more question, people. This is one more question. Reaction of propanamide with ethanolic sodium hydroxide and bromine will give. Okay, a very common reaction, people. This is a very, very, very common reaction. Just let me know its answer. Just absolutely, Praveen, J was very, very easy this time. It was very, very easy, right? Okay, what is going to be the answer of this question, people? It's Hoffman bromamide reaction, right? It's basically the Hoffman bromamide reaction. And how do we get the product in case of Hoffman bromamide reaction? Your amide gets converted into amine. That's it. Amide gets converted into amine. So if you're starting with propanamide, right? You're starting with propanamide, which is CH3, C double bond O, CH3, right? Sorry. Okay, so finally, see guys, if this is propamide, right? If this is propanamide, it's undergoing Hoffman degradation, right? What is going to be the final product? In the final product, there'll be 1 carbon less. From amide, you are basically getting amine, right? And in the amine, 1 carbon is going to be less, right? If this is propamide, what is going to be the final product? You can just solve this question without writing the reaction itself, right? What is going to be it, right? 3 degree gets, in the substrate, you have got 3 carbon atoms. In the product, there'll be only 2 carbon atoms. And from amide to amine, right? So what is going to be the answer of this question? Let me know fast in the chat box. Absolutely, it's going to be ethylamine, people, right? Absolutely, it's going to be ethylamine, right? So have a look exactly. You're starting with CH3, CH2, CONH2, right? Simply do one thing. Take this CO out. Attach this carbon with this nitrogen, so you get CH3, CH2, NH2, which is basically your ethylamine, right? So from your amide, you are getting the amine, right? And in the amine which you are getting from this reaction, there'll be 1 carbon less as compared to the substrate. That's all. Yeah? Okay, let's move on to one more then. The minimum pressure required to compress 600 decimeter cube of a gas at 1 bar to 150 decimeter cube at 40 degrees centigrade, right? Temperature is kept constant. In which gas law do we keep the temperature as constant? It's something which we call as Boyle's law. And what is the basic equation for the Boyle's law? People do expect these sort of equations, right? P1 V1 is equal to P2 V2. What is the pressure of the gas? Initially, that's given to me. It's 1 bar, right? Volume of the gas, it's given to me as 600 decimeter cube, which is basically equal to 600 liters, right? Okay. What is the value of P2? P2 is something which I need to calculate, right? What is the value of V2? V2 is the final volume of the gas, which is 150 liters, or you can say 150 decimeter cube. So from here, you'll be getting the value of P2, right? Which will come out to be in bars. Absolutely, it's going to be 4 bar as the answer, right? 4 bar is going to be the answer of this question. Okay, which of the following statement is correct about bakelite? Bakelite, people, right? A very, very common question which is asked from a couple of years in your NEET as well as in JEE, right? You can let me know its answer first. Bakelite, what is it all about? Is it a linear polymer? Is it a cross-linked polymer? Is it an addition polymer? Is it an branched chain polymer? What is going to be the answer of this question, right? First of all, what are going to be the monomers of this bakelite? The monomers of this bakelite are going to be formaldehyde and phenol, as you all must be knowing. They undergo cross-linking. And lead to the formation of something which we call as bakelite at the end, right? Okay, so it's absolutely going to be option 2. It's a cross-linked polymer in which the monomers are going to be your formaldehyde and the phenol, right? Okay, so bakelite is a cross-linked polymer of phenol and formaldehyde. I'm sure this is clear to everyone, okay? Among the following compounds shown below, which one revealed a linear structure? O3, HOCl, NO2 and N2. There is only one which is going to be linear, and that's absolutely going to be N2. No need to remember this or no need to do something. I'm sure you all will be familiar with the structures of these compounds. There's only one which is going to be linear. That's going to be N2O. Rest all are going to be bent. Rest all are going to be bent. Yeah? Okay. Absolutely, people. So N2O is going to be the answer of this question. Moving on to one more. The reaction of concentrated sulfuric acid with carbohydrates is an example of concentrated sulfuric acid. People, is it the dehydrating agent? Absolutely, this concentrate H2SO4, it is the dehydrating agent, right? So this concentrated H2SO4, it's absolutely going to dehydrate carbohydrates into carbon, right? So this example is the reaction of the dehydration reaction. It's option B, which is going to be the answer of this question. I'm sure this is clear, right? I'm directly moving on to one more question, which is going to be on your screen. Have a look on this. Which of the following compound is most reactive in electrophilic aromatic substitution, right? So basically, these are the substrates which are given to me, right? This is not a coordinate bond or something, it's a normal bond, right? It's a normal bond. It's a normal bond, people. Okay, now, so you're given with four substrates, and you're simply going to check which of the following will undergo electrophilic substitution first, right? Okay. So basically, electrophile is going to attack at these substrates. So where is going to be the electrophile attacking these substrates fastly? In which of the following the electrophile is going to attack these substrates fastly, right? What is electrophile? That is something which we call as electron-loving species. So wherever there will be electron deficiency in the ring, there only the electrophile is going to attack faster. So that substrate is only going to be highly reactive towards electrophilic substitution reaction. So people, have a look. This is NO2 over here, right? Right? So option C is absolutely going to be the answer of this question, right? Is that? Sorry, electrophilic substitution. I'm using electrophile, electron-loving species, so it's not going to be NO2, right? This electron withdrawing, correct? Right, people? So basically, electrophile has to attack. What is an electrophile? Electrophile is electron-loving species. So wherever electron density will be more, that's absolutely going to be more reactive. OH is going to, in this ring, there is going to be more electron density. So absolutely, option. Which one? Which one, people? Option 1 is going to be the answer of this question, right? Yeah? As simple as that. Oh, lone fuck was shocked. Is that? Okay. Perfect. Identify the wrongly matched pair. Which of the following is the wrongly matched pair? NH3 is pyramidal in shape, right? It's absolutely correct. PCl5 is trigonal bipyramidal in shape, right? But over here it's mentioned that it's trigonal planar. So option 2 is going to be the one which is going to be the answer of the question, right? This one is not perfectly matched. PCl5 is basically trigonal bipyramidal, right? All the other things are correct. Okay. Moving on to one more. Which of the following is a free radical substitution reaction? Okay. Propene with HBr, benzene with Br2, acetylene with HBr, methane with Br2HNew. Okay. So people, which of the following is the example of free radical substitution? It is basically going to be the photobromination, right? Photobromination, option D, right? Okay. In which you get free radicals and finally you get alkyl halides as the product, right? Okay, so finally you'll be getting the methyl bromide as the product, right? You'll be getting CH3Br as the product. So this reaction basically is the example of the photobromination reaction in which occurs with the help of free radical substitution, okay? Okay, if for a certain reaction delta H is 30 kilojoules per mole at 450 Kelvin, right? The value of delta S for the same reaction will be spontaneous at the same temperature. For the reaction to be spontaneous, we know. For the reaction to be spontaneous, delta G for the system at constant pressure and temperature, it must be less than 0. This is the criteria for the process to be spontaneous. Delta G is nothing, it is delta H minus T delta S, right? This thing must be less than 0. So, or I can say delta H should be less than T delta S, or you can say T delta S should be greater than delta H, or you can say, what do I need to calculate exactly? I need to calculate the entropy change, delta S, right? So delta S should be greater than delta H upon T, right? Delta H value is given, temperature is also given, kill it, right? But make sure you convert this kilojoules into joules first. So it is going to be 30,000 divided by 450. 30,000 divided by 450, you can calculate it exactly and you'll be getting the answer of the question, right? So it's going to be 30,000 divided by 450, which comes out to be 66.67 joules something, right? Okay. Perfect, guys. Moving on to one more. This is one more simple question. Just kill it. Let me know its answer in the chats. 1 mole of carbon atom weighs 12 grams. That's something which you all must be knowing, right? The number of atoms in it is equal to. What kind of question is this? See. So basically, what do we have? We have got 1 mole of carbon, right? Its mass is 12 grams. 1 mole of carbon will absolutely contain 6.022 into 10 raised power 23 particles of it. So option A, absolutely. A simple basic question. Which of the following oxide is amphoteric in nature? Which of the following oxide among all is amphoteric in nature? We are starting with carbon dioxide, then we have got tin oxide, SiO2, GeO2, right? Which of the following is amphoteric? Can you let me know its answer fast? It's again the easy question, people. It's again the easy question, right? So it's absolutely going to be SnO2. SnO2 is the common example of the amphoteric oxides among these, right? Rest all are going to be acidic. Carbon dioxide is acidic, SiO2 is acidic, GeO2 is acidic, right? There's only one option which is going to be amphoteric, that's going to be tin dioxide, right? Okay, isotonic solutions how? What do isotonic solutions have in common? Isotonic solutions have got same osmotic pressure, right? Again, a very simple question. Okay, how many sp2 hybridized carbon atoms are there in this compound and pi bonds, right? How many sp2 hybridized carbons and pi bonds are present, right? So first of all, let's count the pi bonds. This is C double bond O, this is COOCH3, right? So it is basically from here I'm making it again, it is C, this is C double bond O, this is OCH3, it is something like this, right? And over here it's attached with the triple bonded carbon, then it's attached with the benzene ring, right? With the phenyl ring, I must say. Okay, so how many sp2 hybridized carbon are there? So this one is sp2, 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 this one is sp2. This is sp, right? This is sp, this one is also sp2, correct? So just count the number of sp2 hybridized carbons. There are 7 sp2 hybridized carbons over here, right? So these 6 and the 7 sp2 hybridized carbons. And how many pi bonds are there? See, check it out. 1, 2, 3, 4, 5, 6. So there are 6 pi bonds, right? So 7,6 is going to be answer of this one, right? Okay. So let's move on directly to one more. Which of the following statement is not true about glucose? It is an aldopentose. Lol. Yeah. So this is not correct, right? It is not basically the aldopentose, it is the aldohexose, right? Okay. It's a very common and basic question. This is something which we would have discussed in bio as well. So option A is the only one which is incorrect among all about glucose, right? It is basically an aldohexose and its structure, as you all must be knowing, right? And these are the points about this glucose. It is an aldohexose. There are 5 OH groups, right? It is the reducing sugar as it contains CHO groups. That's something which is very common, which you all must be familiar with, right? Okay, the compound C7H8. What is C7H8 basically? It is toluene. C7H8, it is toluene, right? So you're starting with toluene, right? You're starting with something called as toluene, right? You're doing the chlorination of toluene, right? You're using Cl2 and supplying some heat as well. So what is going to happen? So what is going to be a product over here? What is going to be this A? So I'm using 3 times Cl2 with this delta. So what you'll be simply doing, just replace this CH3 by CCl3. Just replace these 3 hydrogens with 3 chlorines, right? So this is going to be my A, which is getting formed, right? So this is going to be CCl3 over here. Correct, people? Now you're using this reagent Br2Fe. Br2 in presence of Fe, right? Now over here, bromine is going to get attached at which position? Orthopara or meta? Bromine in this case is going to get attached at the meta position, right? So this is going to be your option B. This is going to be your option B. I'm sure you would have studied all this in detail, people, right? This is going to be your Br, right? Now again, I'm going to use Zn in presence of HCl. So what is going to happen? Again, this CCl3 is going to get converted into CH3, right? In presence of this reagent. Again, you are going to convert this CCl3 into CH3. So finally, you are going to get this as the product. This is Br over here. And at the top, what do we have? We have got CH3 in short. So what is going to be the final product? Isn't it going to be metabromotoluene, right? Isn't it going to be the metabromotoluene? Absolutely, it's correct, right, people? So option A is the one which is the correct answer among all, right? You can check it out. Okay, which of the following carbocation is expected to be the most stable, right? See guys, NO2 electron withdrawing, NO2 electron withdrawing, NO2 electron withdrawing, NO2 electron withdrawing. Right here, positive charge over here, positive charge over here, positive charge over here, positive charge over here. Correct? Electron withdrawing groups, what do? They destabilize the carbocation. So wherever the distance between the electron withdrawing group and the carbocation is going to be more, wherever the distance between the positive charge and electron withdrawing group is going to be more, that is absolutely going to be more stable, right? So which one is more stable among all? Check it out. Where is the distance between the electron withdrawing group and the positive charge maximum? In the fourth case, so fourth one is going to be the most stable among all. I'm sure it's clear to everyone, yeah? Right, people? So moving on to one more. Which of the following alkali metal chlorides forms its hydrate? There is only one. There is only one, people. Which of the following forms dihydrate? Which of the following forms dihydrate? Can you let me know its answer in the charts here? It's absolutely going to be lithium chloride. LiCl is the only one among all which forms the dihydrate. The question is directly given in your NCERT. Right, people? It's going to be LiCl 2 times H2. Okay. In the following reaction, the electrophile involved is, this is the reaction, and it's a very, very common reaction, people, and this reaction, as you all must be knowing, that's something which we call as Reimer-Tiemann reaction, right? And what is the electrophile which is involved in the Reimer-Tiemann reaction? Very, very common question, right? Isn't it going to be dichlorocarbene? Absolutely, people, it's going to be dichlorocarbene, which is basically the electrophile in case of the Reimer-Tiemann reaction. I'm sure this is again clear to everyone, right? So this CCl2 over here with the electron pair, right? This is the electrophile which is basically in this, right? Okay, so let's move on to one more. Which of the following which of the following conditions will favor maximum formation of the product? Maximum formation of product, right? So I will have to make sure the reaction moves in the forward direction, because when the reaction moves in the forward direction, then only the product formation will happen, right, people? So I need to make sure the reaction moves in the forward direction. And how come reaction will be moving in the forward direction? Just have a look. Delta H is given negative for the reaction. That means it's exothermic. And when people exothermic reactions move in the forward direction, when the temperature is kept low, right? Low temperature. Okay. And at the same time, see the number of moles of reactants, 1 plus 1, 2. See the number of moles of products, 1, right? So during this process, when this reaction is happening, number of moles are decreasing. When this reaction is happening in the forward direction, number of moles are decreasing. Number of moles are decreasing means pressure is decreasing. So in the forward direction, pressure is decreasing. So if I will have to make sure the reaction moves in the forward direction, do I have to decrease the pressure or increase the pressure? I'll have to increase the pressure, right? I'll have to increase the pressure. Then only equilibrium shifts in that direction in which the pressure decreases. That means the reaction moves in the forward direction. So I'll have to keep the pressure high and temperature low. That's it. Then only formation of this will happen. Okay, formation of more product will happen. As simple as that again. Right, people? Okay, magnesium reacts with an element. We have got magnesium. It reacts with the element X. So magnesium is basically reacting with element X to form an ionic compound. If the ground state electronic configuration of X is 1s2, 2s2, 2p3, right? 1s2, 2s2, 2p3. The simplest formula of this compound is, it's again a simpler one. People, what is the valency of magnesium? As you all must be knowing, 2, right? What is going to be valency of this X? Valency of this X is going to be 3. Just do that bachpan wala crisscross thing, Mg3x2, right? Mg3x2 is going to be the formula of the compound, as simple as that. Yeah? Okay? Perfect. Iron exhibits BCC structure at room temperature. So at room temperature, at 25 degrees centigrade, iron is exhibiting what? It's exhibiting BCC structure. Okay. Above 900 degrees centigrade, it forms into FCC. So if I keep the temperature of same iron as 900 degrees centigrade, what it forms? It forms FCC. What do I need to calculate? The ratio of the density of iron at room temperature, the ratio of density of iron at room temperature. Okay, so density of BCC to that of density of FCC I need to calculate, right? This ratio I need to calculate basically. Okay, assuming molar mass and atomic radii of the atoms remains the same. Okay, so first of all, at 25 degrees centigrade at the room temperature, iron is forming BCC. For BCC, as you all must be knowing, the value of Z is 2, right? And similarly, R is equal to √3A divided by 4 for BCC. For FCC, as you all must be familiar with the fact, Z is equal to 4 and R is nothing, that is A divided by 2 √2. Correct, people? And what is the formula to calculate density of the unit cell? Density of the unit cell is simply Z multiplied by M divided by Na multiplied by A cube. Right? So density of BCC divided by density of FCC, or you can write it like this as well. D is directly proportional to Z, inversely proportional to A cube. Right, people? So you can write it as Z for BCC divided by Z for FCC. Correct? Multiplied by A for FCC ka cube divided by A for BCC ka cube, right? You need to put all these values into this equation. Finally, you'll be getting the answer, right? All these values, every single thing, every damn thing is given to us, right? You need to put all these values into this equation. You'll be getting the density. You'll be getting the ratio of these densities. I'm sure it's again clear to everyone, right? Okay. So finally, I must say you'll be getting option 4 as the final answer, right? You're doing the same thing over here. Finally, after doing a bit of calculation, you're getting this as the final answer. Yeah? Okay, in which case is the number of molecules of water maximum? These sort of questions used to come in JEE long time before, right? And you can again expect these sort of questions. 18 ml of water. What is the density of water? Density of water is 1 gram per ml. If density of water is 1 gram per ml, so what is going to be the mass of this water? Mass of 18 ml of water is going to be 18 grams. So basically I've got some 18 grams of water. So how many moles of water do I have? Number of moles of water I'll be calculating. It's going to be equal to given mass of water, which is 18 grams, divided by molar mass of water, which is 1. So I got the number of moles of water, right? If you have the number of moles of water, you can calculate molecules. 1 mole of water will be definitely containing 6.022 into 10 raised power 23 molecules, right? 0.18 grams of water, right? So how many moles? 0.18 divided by molar mass, correct? The value will come out to be 10 raised power minus 2. These are the moles. Multiply this term by Avogadro's number. These are the molecules of water in the second case. 10 raised power minus 3 moles of water. Just multiply this 10 raised power minus 3 with Avogadro's number. So these many molecules of water are in the third case. 0.00224 liters of water vapors at 1 atm and 273 Kelvin. 1 atm 273 Kelvin. That means STP, right? Okay. And how do we calculate moles at STP? Divide the given volume of the gas by 22.4. And after dividing it by 22.4 liters, multiply the number of moles by Avogadro's number, you get the number of molecules, right? Okay, so what is going to be the final answer of the question? You'll get the maximum number of molecules in the option number 1, right? Are you supposed to calculate maximum or minimum? In which of the case is the number of molecules of water maximum, right? So option 1 is absolutely going to be the correct answer of this one, right, people? Okay, match column 1 with column 2. Again, the similar one. Again, the simple one, sorry. We have got cobalt tripositive, iron cobalt, right? Iron cobalt. Cobalt has got the outermost configuration of 3d74s2, but this is cobalt tripositive, so you are taking 3 electrons out. So 2 electrons will be taken out from here, 1 electron will be taken out from here. So finally, cobalt tripositive becomes 3d6. And 3d6, how we represent it, this is how you represent it, right? 1, 2, 3, 4, 5, and 6, right? This is the outermost configuration of cobalt tripositive. How many unpaired electrons are there? There are 4 unpaired electrons. How do we calculate the spin magnetic moment? It's going to be under root of n into n plus 2 Bohr magnetrons. N value is given to us as 4. So 4 multiplied by 4 plus 2. 4 plus 2 is 6. 6 4s are 24. Root of 24, right? So root of 24. This value attached with this one. Cr tripositive. Chromium configuration. Chromium is 3d5 4s1. Chromium is 3d5 4s1, right? Just take 3 electrons out. 1 from here, 2 from here, it becomes 3d3. So 3 unpaired electrons, under root of 3 into 3 plus 2, under root of 3 into 3 plus 2, 3 plus 2, 5, 5, 3, 15, root of 15. Is the root of 15, right? Okay. Just C is any option matching. A, you're selecting with 4th. B, you're selecting with 5th, right? And there is only option which says A, select with 4th one, and B, select with the 5th one, right? So option A is the one which is correct among all, right, people? Surely it's going to be answer of the question. Moving on to one more. Which of the following element is unable to form MF6 tri-negative? Again, a very common question, people. Boron, it cannot exceed its covalency beyond 4, so it cannot form 6 bonds over here. It can never form 6 bonds. That's something which you all must be familiar with. Yeah? So boron cannot form BF6 tri-negative, right? Because it cannot exceed its covalency beyond 4. So boron is going to be answer of this question. Rest all the elements will do because they have got the vacant orbitals and so on. Yeah? Okay. For the reaction, activation energy EA is equal to 0. The rate constant at 200 Kelvin is this much. The rate constant at 400 Kelvin is this much. Okay, the rate constant at 400 Kelvin will be. Again, the simple question. See, as you all must be familiar with the fact, Arrhenius equation, people, you would have studied, right? There is one form of the Arrhenius equation, which I think that is something log of K2 divided by K1 is equal to EA divided by 2.303 R multiplied by 1 upon T1 minus 1 upon T2. I hope you remember this equation, right? Log of K2. K2 means rate constant of this reaction at temperature 400 Kelvin. K1 is the rate constant of the same reaction at temperature 200 Kelvin. See, activation energy is 0. EA value is given to us as 0. This value is 0. If this value is 0, that means right hand side becomes 0. If right hand side becomes 0, that means log of K2 divided by K1 comes out to be 0, right? Log of K2 divided by K1 to the base 10. This comes out to be 0. Now, I can say K2 divided by K1, it's simply going to be equal to 10 raised power 0, that's 1, which clearly says K1 will be equal to K2. So, there will be no change in the rate constant. So, K1 is absolutely equal to K2, right? This is K1 and K2 will be again 1.6 into 10 raised power 6 only, right? So, which option satisfies it? Option C is going to be answer of this question, right, people? I'm sure it's clear. Right, again a simpler one. Kill this one as well. The correct option representing a Freundlich's adsorption isotherm, right? Let me know fast in the charts. Let me know fast. X divided by m is equal to Kp raised power 1 by n, and 1 by n value, it lies between 0 to 1, as you all must be knowing, right? We have discussed this in detail. Extent of adsorption, that's X divided by m, it's equal to K multiplied by P raised power 1 by n. This 1 by n value, it lies between what? This 1 by n lies between 0 to 1. And there is only one option which says 1 by n is lying between 0 and 1, right? So option 2 is going to be the answer of the question, right? Perfect, guys. Let's move on to one more then. This is one more question. Which of the following is paramagnetic? Again, the question which we can solve as per the molecular orbital theory is concerned, right? You need to write the molecular orbital configuration of all the species, and wherever you see the unpaired electrons, that's going to be paramagnetic. Wherever there won't be unpaired electrons, that's going to be absolutely diamagnetic. In case of O2, there are two unpaired electrons. In your pi star 2px, there is one electron in pi star 2px and one electron in pi star 2py, right? So in O2, there are two unpaired electrons, which makes it highly paramagnetic, right? Rest, in all the other cases, if you write their molecular orbital configurations, you won't be finding any unpaired electron. If there is no unpaired electron, that means all the others are absolutely going to be diamagnetic, I'm sure. Again, it's clear. Yes, someone is asking, NEET kab hai? Nice. Okay, moving on to one more. Which of the following is the correct order of the dipole moment? Which of the following is the correct order of dipole moment? First of all, have a look. H2O, NF3, NH3, BF3. First thing, BF3, its dipole moment is 0. Very common question. Its dipole moment is 0, right? Among these three, which one will have maximum dipole moment? Where is the more electronegative element present? Oxygen is the more electronegative element present over here. Okay. In case of water, the dipole moment is going to be maximum. That's something which you all must be knowing. In case of water, the dipole moment is going to be maximum, and in case of BF3, dipole moment is going to be minimum, right? Now people, among NH3 and NF3, where is the dipole moment maximum? Among NH3 and NF3, NH3 has got more dipole moment than that of NF3, right? Okay, do remove this as well. Now select, see which of the option resembles with this one. That's going to be the answer, right? So option C is the answer of this question, people. Yeah, perfect. Moving on to one more. If the density of a 2 molar aqueous solution of NaOH is 1.2 grams per centimeter cube, the molality of the solution. See guys, there is a one simple result which I have given in the normal sessions as well. What is that result? Molality of the solution is equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute, right? This is the result, direct result between molality and molarity. Now people, molarity is given, this value is given to us, density of solution, it's again given to us, right? Molarity given to us, molar mass of solute. Solute is my NaOH, and NaOH has got the molar mass of 40 grams per mole. Put all the values into this equation, kill it, right? Yes, so finally you get the answer as 1.67. So molality of the solution is absolutely going to be 1.67, right? Okay. Perfect. In hydrogen atom, the de Broglie wavelength of an electron in the second Bohr's orbit. In hydrogen atom, the de Broglie wavelength of an electron in the second Bohr's orbit, right? You have discussed one relation, that is 2 pi r is equal to n lambda, right people? What do we need to calculate? We need to calculate lambda. Lambda is simply going to be equal to 2 pi r divided by n, right? Now he's asking about the de Broglie wavelength of the electron in the second Bohr's orbit of hydrogen. Second Bohr's orbit of hydrogen. N is equal to 2. If n is equal to 2, I'll say radius of the electron or radius of the second Bohr's orbit, that's absolutely going to be equal to r naught n square divided by z. Z value is 1 for hydrogen and the value will be in angstroms. So r is going to be equal to 0.529 n square. N square means 2 ka square. 2 ka square is 4, right? Or you can, this value is in angstroms, but in the question the values are given in picometers. So you can write it as r is equal to 52.9 multiplied by 4 picometers, right? You got the radius of the second Bohr's orbit. Put this value of r into this equation. Put the value of n as 2. Kill the equation. So lambda is going to be equal to 2 multiplied by pi multiplied by r value is 52.9 multiplied by 4. N value is 2, right? Now kill it. Kill the equation. The answer is going to be in pi. So finally, 4 multiplied by 52.9 will be 200 something, right? So it's going to be 200 something multiplied by pi. 200 something multiplied by pi ppm, right? So option C is the answer of the equation. Simple. Yeah? Yes? I'm sure it's again clear to everyone. Let me move on directly to one more. Most stable carbocation among the following, right? Carbocations are stabilized by hyperconjugation, right? So how many alpha hydrogens this carbocation has, people? So there are basically these two alpha hydrogens. So this carbocation is stabilized by two alpha hydrogens. This carbocation is stabilized by how many alpha hydrogens? Only 3 alpha hydrogens. This carbocation is stabilized by 2 plus 2, 4 alpha hydrogens. And this carbocation is stabilized by 2 plus 3, 5 alpha hydrogens. Wherever alpha hydrogens are maximum, there only hyperconjugation will be maximum, and wherever hyperconjugation will be maximum, there only stability will be maximum. So which of the following will be maximum stable? Option 4 is simple answer of this question. Yeah. Okay. Ammonium chloride in acidified aqueous solution forms a complex A. So when ammonium chloride is treated with the acidified aqueous solution, what is the complex A? If you remember, this again the NCERT based question. After ammonium chloride is put into acidified aqueous solution, you get AlH2O6 tripositive as the complex, right? Yes. So you get AlH2O6 tripositive as the complex when your aluminum chloride is acidified, is treated with the acidified aqueous solution, right? Now people, what is the hybridization in this case? It's a very common thing. Hybridization cannot be D2sp3, it's going to be sp3d2, right? So I must say option 2 is the answer of the question, which majority of the students have already given. Yeah? Okay. Perfect. Moving on to one more question, people. Okay. When neutral or faintly alkaline KMNO4 is treated with potassium iodide, okay, potassium iodide, iodide ions are converted into IO3 negative, right? Simple redox question. Yeah? Yeah, people? What is going to be the answer of this question? This question was repeated in this year's JEE mains as well. The same question was asked. The same question was asked, people. Okay, it's going to be IO3 negative, and this is the reaction. This is the reaction. Yeah? Okay, and remember, if the same question was asked in the acidic medium, remember I negative in acidic medium gets converted into I2. So basically your KMNO4 or K2Cr2O7 converts I negative into I2 in acidic medium, right? But in basic medium, it gets converted into IO3 negative. Yeah? हाँ जी, इतने ही easy questions NEET में आते हैं. This is going to be your level of the NEET examination. Trust me on that. You'll get to know tomorrow, people. Okay, the crystal field stabilization CFSC for COCl64 negative is given to us as this much. The value of CFSC for this compound. So people, as you can see over here, this is the octahedral complex. This is the tetrahedral complex, right? There's a relation that is delta T is equal to 4 divided by 9 delta naught. I hope you remember this. Delta naught value is given to us as this much, right? So 4 divided by 9 multiplied by how much? 4 divided by 9 multiplied by 18,000. Just solve it. That's going to be the answer of the question. That's delta T. Okay. Right, people? So answer is going to be 8,000, right? There is one more question, people. You're going to match column 1 with column 2. Simple. Copper, is it a non-metal? No way. Copper absolutely is a transition metal, right? Fluorine, what is it? Fluorine is a non-metal, correct? Fluorine is a non-metal. Silicon, it's a metalloid. Cerium is a lanthanoid. Now, just match it. That's going to be the answer of the question. Yes? Right, people? So, moving on to one more. At standard conditions, if the change in the enthalpy of the given reaction, I'm given with the change in the enthalpy of the reaction, delta HR I'm given with, right? It's given to me as how much? It's given to me as minus 109 kilojoules per mole, right? This is the reaction. If the bond energy of H2 is given, bond energy of Br2 is given, right? What do I need to calculate? Calculate the bond energy of HBr. I need to calculate bond energy of HBr. I'm sure you would have studied one relation. Enthalpy of the reaction is basically equal to bond energy of reactants minus bond energy of products, right? Is basically equal to minus 109 kilojoules per mole, whatever. Yeah? Bond energy of reactants. Let's start with this, right? The stoichiometric coefficient is 1. So I'll say 1 multiplied by bond energy of HH. Okay? This is again one of the reactant. So plus bond energy of BR bond, right, people? Because the stoichiometric again is 1, stoichiometric coefficient. This is the bond, this is the total bond energy of the reactants minus bond energy of products. So it's going to be 2 times the bond energy of HBr, because the stoichiometric coefficient was 2 over there, and this value is basically equal to minus 109, right? This is something which is given to me. This is something which is given to me, right? This is something which I'm supposed to calculate, right? This is something that's given to me. Just solve the equation, kill the equation, that's all, right? A very simple one again. So finally you get the answer as 368 kilojoules per mole, right? Just do the same procedure, just solve the equation, get the answer. Yeah? So people, this was all from my side in the tonight's session. I'm sure you'd have liked the questions, and I'm sure people, I'm sure you guys are going to do good definitely in the tomorrow's session, right? Yeah? So I wish you all the luck from my side. Good luck, right? Do good, people. Yeah? So with this, our NEET 2021 journey came to an end, right? So again, tomorrow, right after the session, you'll see me right here in front of you on this channel, okay, solving the NEET 2021 paper for you guys, right? So right after 15 minutes of your NEET examination, right? I mean, right after your NEET examination at 5:15 sharp, I'll be coming up live on this channel with the paper discussion, right? Okay. So with this, I take a leave here, yeah? Again, I wish you all the luck. May God bless you, right? May everything falls into place for you, yeah? So take care and good luck, people. Bye-bye. Take care.